Okay, so good afternoon, everyone. Welcome to the second webinar of this week of webinars of the ECMWF Sum of Weather Code. For the ones who don't know what ECMWF is, it's the European Center for Medium Range Weather Forecasts, and we are both a research institute and a numerical weather prediction organization. So producing 24 hours, 7 days on an operational basis, weather predictions for numerical weather organizations and for our member states. And the Sum of Weather Code program is, it was run for the first time this year, and it's a program, it's an online collaborative program where we invite developers, startups, students, and scientists to work with ECMWF in a virtual way, so like not at ECMWF, but virtually for 4 months during the summer on innovative weather-related code. And so since May, we had 5 projects this year. Since May, 5 teams teamed up with ECMWF mentors. And today, the outcomes and the results are presented from the project where Declan Valters worked on. And it's about representing NetCDF files as a virtual file system. And the ECMWF mentors are just on my side. It's Blasej Kreminski and Francesca Di Giuseppe. And and as I said, Declan Valters from the School of Geosciences at the University of Edinburgh submitted a winning proposal. The structure of this webinar, for the ones who joined already yesterday, it's the same. So after this short introduction, Francesca and mainly Blasej will present the motivation behind this challenge and how it will be of need and of benefit for ECMWF. And then afterwards, Declan will present what he developed and how it can be also useful for the wider open source community. And during the presentation, we ask you to mute your microphone, but after the presentations, there will be room for questions, and don't hesitate to ask any question you will have probably. And then I will give the floor to Blasej, and I wish everyone a good time.
Yeah, thank you. So as Julia said, this NetCDF file system project is 4 people. So Declan was developer. He's a research software engineer from University of Edinburgh, and us 3 were helping him as mentors. The collaboration was done mostly through Github, and we also had 2 weekly meetings over the BlueJeans. Yeah, so okay. So this project was about creating a new kind of tool for accessing, browsing, and editing NetCDF dataset. So NetCDF is a common format in geosciences to exchange and store data, and it has a kind of hierarchical structure. So you have data set, which is divided into groups, and the groups can contain variables, and variables in turn can have data arrays and attributes, metadata attributes. So this kind of hierarchical structure, and actually the NetCDF documentation explains this structure by comparing it to a file system. So there are similarities, but for me the big difference between this and file system is that it's extremely easy to work with a file system. You can easily rearrange your files and directories. You can add files, rename, and you can do it using tools that most of them come with your operating systems. So command like copy, mkdir, and so on. And in case of NetCDF, you have this container, and so you are isolated from your data in a sense through this box, and you need a set of specialized tools to access this box. So in this project, we tried to develop a software which would allow represent the NetCDF dataset as a regular file system. So it would map NetCDF objects like data arrays, attributes, groups into directories and files. And it would also map file system operations into calls, into NetCDF library calls. And this would allow people to manipulate the structure of the dataset using common operations like copy and clear, edit the contents using text editors, for example, and browse the contents with file managers and so on. Yeah, so for us, it would be very useful to have this kind of tool. We use NetCDF in a few projects at ECMWF, and it's very often that we get a data set and something is not quite as we need, and we need to change something in the file. So typical tasks that we've done in the past is fixing time coordinates, because, for example, dates were shifted in the file. We also had a case where we had to remove all the data from the NetCDF file. So in a sense, create a template which contains only metadata and dimensions, and then we had application which would fill this template with actual data. And other task is like renaming variables, dimensions, adding attributes. Yeah, so the way we would do it so far was, okay, most of the time we know what we want to change exactly in the file. For example, you want to edit some attribute, but we are not sure how to do it, so we need to go to Google and find solutions, learn new tools. And sometimes it's just fastest thing is to use this NCDump utility, which is something that comes together with the NetCDF library, and it converts entire dataset into text, and you can edit this text, and then you have reverse operation when you can regenerate NetCDF from the text. And it works fine for small files, but if you have file which is several gigabytes, the size will explode, and you may not even be able to edit the file. So if we had a way to represent the dataset as a file system, we could use a favorite tool to do this change, like open the attribute in the text editor and just edit the text. Yeah, so that's the general idea behind this new approach. Yeah, just to give a concrete example, we got a time series NetCDF file, which had precipitation observations for a couple of time steps. And so the time coordinates would be encoded as a series of numbers, and then there would be an attribute called units, which basically describes what are units of these numbers. And software uses these two pieces of information to figure out what are the dates of the observations. So here is an example output of we are listing the contents of the file, and obviously the dates are interpreted in the wrong way. So something is wrong. In this case, what happened is that this data was cut out of the larger time series, and someone for some reason changed this units string. Originally it was 1990. So a simple fix for that was to edit the time unit string. And with this kind of tool where you can open an attribute as a text file, it's extremely easy to fix. If you don't know the tool, you need to spend some time to figure out how to do the change. Okay, so benefits. Yeah, I think it would be a very general purpose tool. I see it as a good tool for doing this kind of quick and dirty changes, like a sculpting tool for NetCDF. Not necessarily for production quality code. I would still think that writing proper script would be better approach. But for kind of development or prototyping applications where you need to create some kind of test input, I think would be very useful. It may simplify some kind of operation, for example, changing attributes like missing value in the file. Yeah, so that's all for introduction. We switch over to Declan, and he will explain his implementation.
Okay, so hi everyone. My name is Declan, and as Bajir was saying, I'm a research software engineer at Edinburgh University in Scotland in the UK. And I've been working on this NetCDF represented as a file system project over the last few months with a lot of help from my mentors, Bajir, Francesca, and Kevin. So at the university, we also use a lot of NetCDF files. We do climate modeling and things like that, and generate a lot of NetCDF output. So this was a useful project for us as well. So in this presentation, I'm going to just go over the sort of more technical details of how we implemented it and what we did, and show you how it works. Let's see if this works. Sorry, just a minute. Okay. So I've written this Python package called FuseNetCDF, and it's written in Python 2.7 and 3 compatible code, so you can use it whichever Python version you're using. Although we did most of our testing on Python 2.7, but it should work in Python 3 as well. So one of the benefits is that it runs in user space, so there's no root privileges required to run it. It uses what's called a Fuse file system, which is a file system in user space. So that gives you the ability to run it without, as I say, being an administrator or a root user on Unix. And so what it does, it takes a single NetCDF file and it represents it as like a mounted directory on your Unix system or Linux system. So the NetCDF file appears as if it were a folder or a directory, and the files correspond to the various bits and pieces of the dataset, like variables and attributes, global attributes, and so on. It's very simple to use, so it's a command line utility. It's written in Python, but you use it as like a command line script. You just type single command to mount a NetCDF file, NCFS, and then the name or the path to the file, and then you create a directory where you want to mount it, and then it mounts it. And then your NetCDF file becomes a file system, a virtual file system. So inside the mount point directory, you have a list of global attributes from the NetCDF file, which appear as text files, and then all the NetCDF variables appear as subdirectories. And within those directories, you see the variable attributes and a representation of the variable data itself. So to show you how it works, I think we'll start with a short video, just a few minutes long, and I'll talk over the video of how it's working. Let's see if this works. Okay, so I'm in FuseNetCDF folder. This is the code from GitHub, by the way. That's what it looks like if you were deploying the code. And it's all in a single file called FuseNetCDF.py. So I've created an alias on my system called NCFS, which points to this script. And if you type help, you get the very basic help printed out from the screen there. It's quite a simple interface to use. So in the folder called trial, I've got some trial NetCDF data, which I'll ls in a minute. So we're going to use this ECMWF era 40 dataset to play around with. So first of all, you make a directory that you want to act as your mount point for the NetCDF file. So we've made that there. And now we've got our mount point in the folder. And then we use the ncfs command to mount the NetCDF dataset to the mount point. And so when I did this, I was running this in the foreground, so you could run it as a background process. So I'm going to open up a new tab, hopefully, and there we go. So it's still running in the background, but we've just opened up a fresh tab there. So I'm still in the same folder. So now I've got our mount point folder. And if we go inside that, it should contain all our NetCDF variables. So that you can see like typical variables from a NetCDF file and some global attributes metadata as well. So that's what it looks like. It just looks like a standard Linux directory that you'd see, but you've got all these subdirectories that contain the variable names. So just go back up. So just to sort of verify this, let's have a look at what ncdump looks like. We should run this first. There you go, we've got all the variables there from our NetCDF dataset that correspond to the subdirectory names in the mounted point. So it's a fairly standard NetCDF file, lots of variables, variable metadata, and we can use NetCDF to have a look at this data. So if we go back into our mount point, this is the variables again. We've got our corresponding variables, variable names appearing as directory names. And if we print out, say, let's print out the history, which is a global attribute, it prints it out to the screen, just using a simple Unix cat command. It can do the same for the conventions, global metadata. Tells us what convention we're using, CF 1.0. And you can open these files with a standard text editor like Vim or gvim or gedit, whatever you like to use. And you can also edit them. So if we wanted to add to our history, global attribute, put something in like another comment or something, save that, write it out, and it writes it directly to the NetCDF file. And there it is again. We'll just put that through the cat command, and you can see our history comments appeared. And that's written straight back to the NetCDF file as well. So let's have a look at our variables. So this is the BLH variable, or boundary layer height, I think it is. Just cd into there. So now we've got all our variable attributes, and we've got two of the files that you'll see, the data repr and the dimensions file. And we can do the same as we did with the global attributes, just print them out with cat, print the long name attribute out, so it's boundary layer height. Let's have a look at the missing value. And you could edit these as well, just like we edited the history attribute previously. And we can have a look at the fill value as well, which is the same. So all these attributes just have basic textual representations that are editable and writable. So if we stay in the same folder, and let's have a look at the data repr. So this is how the data variable itself is represented. So as a basic sort of interface, it just represents it as a straightforward textual representation, and catting it to the screen is perhaps not that helpful, but you can edit it, like I say, in a text editor like gvim. So we'll just cancel that. And it's the same for the so yeah, if we just go back up to the mount point, so the structure looks like a standard Linux directory system. And that's just looping through all the variables, printing them out, how it looks. So now if we go to our graphical browser, so it appears as a mount point, like if you mounted a hard drive or a removable media, and you can browse it in the graphical file explorer as well. And you get the same thing, so it's variable attributes, and you can edit these in sort of visual text editors as well. And then we've a dimensions file that gets generated that tells you what the dimensions are for that variable. And then again, we've got the variables appearing as directories, subdirectories, and so on. So that's a basic overview of what it does. Okay, so that's the video. Let's have a look at how we implemented it in a bit more detail. Let's start the video again, sorry. So for example, you might want to rename dimensions. That's something that I do quite often with the work that I do. So we can do that as well. That's another quick video that just goes through this. So I've mounted the same NetCDF file again at the mount point, and we're going to use the utility to rename the dimension. The screen there. And let's just inspect the data again. So you'll notice that our lat and long variables are called latitude and longitude. So we're going to rename those using the NCFS utility. So we're going to our mount point, ls, just to check where we are, and you can rename it just using the move command, the Unix move command. So that's how you rename a folder, and there you go, it's been renamed from latitude to lat. We do the same for longitude, rename it to long, and they've both been renamed now, lat and long. So just to double check that, let's go into the lat folder, the variable, have a look at our dimensions file, and there you go, it's been renamed to lat. Just go back up to a directory, look at the dimensions, and there you go, it's renamed both lat and long in the dimensions file as well. So it's checking that all the appropriate parts of the file have been renamed correctly. And if we open our file again, you can see that it's been renamed to lat and long. So all the variables have had the dimension variable correctly renamed. So just thought I'd spend the next few minutes just going over what Fuse is and how the software works. So as I said at the start, it's using something called Fuse file system in user space. And what it does, it's a Linux or Unix software library that lets users create custom file systems. And it does this without the need for any root privileges or system level access like administrator access. And you don't need to know anything about editing Linux kernel code, which is quite good if you're a developer as well. And so in the diagram on the right, it's just illustrating how it works. So it sort of sits on top of the Linux kernel in user space and interacts with the lower level libraries, but providing a sort of easier to use API for developers. It's all on GitHub, so if you wanted to have a look, you could have a look at the sort of underlying libraries there. So they're C libraries. And it's used for quite a few things as well. So it's used for a Unix utility called ArchiveMonth. So if you've ever opened a tarball or a zip file on Linux, you'll notice that it maps the tarball without you having to actually unzip it directly. So you can view a zip file or a compressed folder. And underneath that, it's actually using the same Fuse file system, Fuse library that we're using here. And it's used for things like SSHFS, so viewing a file system over a secure shell, and that's the image on the right there. And there's also some slightly perhaps more trivial examples like WikipediaFS, which actually maps Wikipedia to a file system, a virtual file system, and you can edit Wikipedia just by editing the actual text files, which is quite cool. So it's got a lot of different uses. And if you're interested in more details, you can go to the Wikipedia page, have a look. So what I used was something a bit higher level. So there's the LiveViews, which is a C library, but then some people have written this library in Python called FusePy, which is a higher level Python interface to the C library. And it's a much more, I would say, a much more user or developer friendly Python-based library that interacts with this C-level library. And again, that's on GitHub. The link's there if you'd like to have a look at that. Documentation is a little bit sparse, so I think they are developing the documentation further at the minute. So yeah, it's a case of sort of going through the code and working out what it does, and there's some trial and error involved there. But it's a very good library. Very nice interface to the C-level bindings. And then the second Python library that I'm using is NetCDF for Python. So if you're a NetCDF user and you use Python as well, you've probably come across this, so you might use it. And that's another Python API to the sort of lower level C NetCDF libraries. And it supports features like writing, reading, editing NetCDF files as well. But some features are not supported, like deleting variables, as we discovered. So what we did was we put those two together, FusePy and Python NetCDF, and came up with Fuse NetCDF, which is what I was just demonstrating a few minutes ago. So again, the way that it works, it maps common Unix commands like cp, makedir, cat, move, and so on to corresponding features in the NetCDF for Python library. So if you move a variable directly, for example, that connects through to the rename function in the Python NetCDF library. And you end up with this nice navigable file system for your NetCDF file. So we've implemented quite a few features over the last few months. So for variables, as I showed, variables show up as a directory. The sort of standard representation at the minute is a text file. It's just if it's sort of array-like data, it's a NumPy array printed out in string format. We've also got some sort of plugin-like functionality. So if people are keen to develop new representations, like images, for example, that would work as well. Sort of future development. And it does things like renaming variable directories, renames corresponding variable in the NetCDF file. If you copy a new variable, if you copy an existing variable, that creates a new variable in the NetCDF file. The dimension variables are represented as editable text files. For attributes, so if we delete an attribute, it deletes it from the NetCDF file. Same for renaming, and same for creating new attributes. So if you were to open up a blank text file within the mounted NetCDF dataset, it would create a new global attribute or a variable attribute, depending in which level of the directory structure you're in. So at the minute it just runs on Linux, so we've tested it under various flavors of Linux, and it'll read both the NetCDF 3 and 4 files. So development wasn't quite so straightforward as lots of software engineering projects rarely are. So we had a few challenges during development. So as I mentioned a few slides ago, FusePy and Fuse itself, these are had quite steep learning curves if you're not used to being a Linux systems programmer. FusePy sort of lacks reasonable documentation, although it's improving. LiveViews, the C library, is actually very well documented, but there's not always a nice sort of one-to-one mapping between FusePy and LiveViews. So there was quite a lot of trial and error and quite a long experimentation period at the start of the project, which took a bit more time than we envisaged, but it's all a useful learning process. And then for Python, the Python NetCDF bindings that we used, so there were one or two limitations that we discovered towards the start of the project that sort of prevented me from implementing certain features straight away, like deleting variables, for example. So you can't do that quite so easily using Python NetCDF, although we came up with potential workarounds that we might implement later if we have time. So originally we hoped to map multidimensional variables, by which I mean things like variables that have, say, model output with multiple model layers. We would have liked to map those to like a subdirectory structure where each model layer would have been represented as a subdirectory. But the way the code sort of evolved naturally, prevented us from doing that towards the end, so that would require a bit of changing to the original structure of the code. But we think it is doable in the future. Deletion of variables, as I said, that's a limitation with the Python NetCDF 4 library, but we came up with a potential workaround for some future work. And we also had slight problems defining how the user would create new variables and change their type, for example. And these are all, if you'd like to have a look, if you're interested in contributing, these are all on the GitHub page for the software under the issue tracker. So in the future, as I mentioned, we'd like to sort of extend how variables are represented and how the editing capabilities would work. And the way that we've done it, although actually this is Blagier came up with quite a nice way of developing these plugins for representing variables. So I think there's lots of potential for future development there. And then another thing we'd like to see implemented one day would be validity testing, so checking that it's the variables are CF compliant, for example. And we will shortly have a pip or a conda, probably a pip package that you can install from the PyPI repository as well. So that should appear very shortly. Like I say, we're open, it's all open source. We very much welcome contributions. If you want to fork it and start doing your own development work, have a look at the issue tracker for what we've been working on, what we're stuck with. And yeah, we welcome pull requests, suggestions through GitHub. So thanks very much, and I'll take any questions or comments or suggestions. Thanks.
Well, thank you, Declan. Thank you, Blagier. Are there any questions from the weather room or from the audience online? So we have one question. If you had 4 more months, what would you do to improve this prototype?
So I'd like to see basically the last slide I showed, so I'd like to see these sort of outstanding features implemented. So I think the validity testing in particular would be quite useful to check that your attribute values are the correct type and variables conform to CF standards. Be really good to have. I'd also personally like to see the variable representation part of the code extended. So one of the ideas I had at the start, which sort of ran out of time to implement, was having arrays or variable data represented as sort of low resolution image files. So you could look at a variable like, I don't know, whatever, sea surface temperature, and just have a really nice, quick and easy representation through a PNG image. Like you get with NCView, for example. So that'll be something I'd like to see implemented. Yeah, those two things would be very good.
Okay, thanks. Are there any other questions? Oh, another one. This is a very cool idea. Is it possible to change the record dimension from fixed to unlimited? That would be cool.
Okay. Yeah, that's a good question. I don't know if we actually test, so you can't do it. I don't think you can currently do it through the current code, but yeah, that would be a cool idea. Yeah, we'd have to test that. Yeah, that would be a nice feature to have. Yes.
Okay, and then we have another question. What happens if coordinate variable doesn't have the same name as the corresponding dimension?
If the coordinate variable doesn't have the same name as the corresponding dimension.
I think it's not coordinate variable by definition then.
Yeah. Is that right? Yeah.
Because it needs to have the same name.
Yeah.
Right, yeah.
And then there's another question, and I can't see it because of the resolution.
Oh, what type of...
validity testing would you implement?
Yeah, that's a good question. I suppose like sort of basic sanity checking on variables or attributes. So if you're adding, if you're changing the time from attribute, just checking that it's a valid, date time format, not letting people edit any sort of random text into certain attributes like that. I don't know if anyone else has any suggestions on that.
No.
No. Okay. Yeah, just like general sanity checking, I would call it, really.
Yeah, I mean, there is a slight, yeah. So it may happen that the user does something that is not valid from the NetCDF point of view, and we need to check for this, and then we need to communicate back to user that he did something weird. So we did it by issuing permission denied file system error.
Yeah, that's a good point.
And your edits are ignored.
Yeah.
Yeah, makes sense. There's another question. Is it possible to copy variables to one file to another? Or a variable to one file to another?
No, not as it currently stands, because you can, I suppose you could mount two files at the same time, but you can't copy one from the other. But that might be a useful feature to have, actually. Yeah, that's a good point. That would be a useful thing to do.
Do you have like a list on GitHub for future developments?
Yeah. So if you're on GitHub, I think you can see the screen on the left, the screen that I'm showing now. So if you go to the my GitHub username dvalters and use NetCDF, and then on that page there's an issue tracker. And if you have a suggestion or you find a bug, feel free to go there and open up a new issue. So we've got a list of things like passing errors back to the user, the PyPI things up there as well. But if you have any suggestions, you can open that as an issue. So just open up an issue and I'll get an email about it.
Okay, so we have three more questions.
Yep.
So one is, what happens to the mounted NetCDF file if the mount point directory is incidentally deleted?
If you delete the mount point. That's a good question. I'll find out shortly and I can get back to you on that. That's a good thing to test, actually. I'm hoping it doesn't delete the NetCDF file. But yeah, good question. Yeah, well spotted.
Okay.
I'll check and find out and make sure it doesn't delete it. I don't think it does, but I'll check.
Another question, would you be interested in developing this towards NetCDF as a database, whereby users could query the data for a given set of constraints, for example, timestamp, latitude, longitude, or is that out of scope for this project?
It's a really cool idea. It's probably out of scope for this particular project, but like I say, if anyone would like to take this further or develop that kind of functionality, they're more than welcome to. And yeah, that sounds like a really cool idea, like querying the dataset. Yeah, NetCDF as a database. That's a good idea. Yeah, it's sort of a little bit beyond the scope of the project, but I like the idea. Yeah.
Okay, and then can we mount in read-only mode?
So no, not as it currently stands, but I think that would be relatively straightforward to implement. Yeah, another good suggestion for the issue tracker there on GitHub there. Yeah, that would be a useful feature as well. Yeah, these are all good suggestions. Thanks.
And do you think will you already be able to use it in your day-to-day work, or you think it's like still you would need some more developments to be fully flexible?
So right now, I mean, things like just renaming the dimension variable names is something that is now really easy using this package as it stands. Being able to create new variable attributes, edit variable attributes is really useful, which is already implemented. So in that respect, it's useful as it is already. And then, yeah, all the suggestions that that came up in the questions would be really useful to have as well in the future. So yeah, there's lots of scope to extend it and develop more functionality, but I mean, for my work personally, it's already quite a useful tool with lots of scope to develop it further, I guess.
Mm-hmm. And then what happens if you rename a variable to an existing one in the file?
You should get the permission denied error, I believe, that Blasier was mentioning earlier on.
Yeah, I think ideally the behavior would be the same as a regular.
Yeah, you get.
I don't remember what you get if you try to copy, if you try to move something that already exists. I think you get something like file exists.
Yeah, that's right. Yeah.
That's what should happen. Yeah.
Yeah, you get the standard file system response for that.
Okay. Are there any other questions? But I think we already had quite a few. Okay, so thank you, Declan and Blasier, for the presentation. And for all the people who joined in the weather room or online, there is another webinar tomorrow at the same time with the same link credentials. It's another project which was developed by the Summer of Weather Code. It's about migrating an existing code for a calibration software that is used at ECMWF into Python, and also the development of this GUI for the software. So if you're interested, we would be happy if you join also tomorrow.